The question is like this. Uh, Suppose what I want to say is, suppose there is a disk. This is the disk of radius r. Okay. Disk of radius r. Now, from this disk, suppose where will be the center of mass present? This point I might have told you. For if mass is distributed symmetrically, did you write this point?
No, sir.
Symmetrically over a point, mass is distributed symmetrically over a point, then that point of symmetry is called as center of mass. You know this?
No, sir.
Okay. Suppose a ring is there, right? Ring. So now this entire mass of the ring is distributed symmetrically over this point or not? Symmetrically. This ring has symmetry, right?
Yes, sir.
Now the square is the square plate. If you see exactly above this point, everything is symmetrical, right? Left side, right side, above and below.
Yes, sir.
Now then, that point of symmetry, geometrical center will be the center of mass. Got it?
Yes, sir.
If entire mass is distributed symmetrically over a point, that point will be actually the center of mass, geometrical symmetrical point. Okay.
Yes, sir.
Now here, if it is not uniform, then it is not symmetrically distributed.
Yes, sir.
This is uniform, entirely the disk is uniform. Then only that symmetry is there. Got it?
Yes, sir.
This you can make it as a note point. Now, the concept is, now here the disk is there, which is of, here the disk is there. Now in this is a uniform disk. As of now, you don't know the mass or anything else from here. So, but now the question asked is, from this disk, here radius of r/2 disk is removed from the disk. What is removed? r/2 radius disk is removed. r/2 radius disk is removed. Now the question is, where will the center of mass of the remaining disk be present? Where will the center of mass of the, where will be the center of mass of the remaining disk present? Center of mass of the remaining disk present at where? Now, if entire disk is present, where will the center of mass be present? Is it the center or not?
Yes, sir.
Because it's a disk, uniform disk, isn't it?
Yes, sir.
Now what I will treat is, I will treat it as two bodies. This is M1 body and this is removed part is M1, M2 body. Remaining part is M1 body and removed part is M2 body. Okay.
Yes, sir.
Then both of them, if they're kept like this, where will the center of mass present? Center, right? If both of them are
Yes, sir.
present. Are you getting?
Yes, sir. We are getting, sir.
Both of them are present, the center of mass will be at center. So what I will do, I will use the main formula. The center of mass of the total mass, that is M1 plus M2, I will treat it as total mass M. Okay.
Yes, sir.
Now center of mass of the total mass is origin, right? Here.
Yes, sir.
I'll
Z axis.
that is X x center of mass. So x center of mass of
Yes, sir. X center.
is equal to m1 x1 plus m2 x2 divided by m1 plus test. Got it?
Yes, sir.
Similarly, y center of mass also you will write here m1 y1 plus m2 y2 divided by m1 plus m2. Got it?
Yes, sir.
Now the important point is, what do we want? The center of mass of the remaining part means x1, right?
Yes, sir.
That means m1 mass center of mass. That is nothing but x1, right?
Yes, sir.
For entire body, x center of mass means m1 into first body into center of mass of the first body, second body into center of mass of the second body by m1 plus m2. Got it? This formula.
Yes, sir.
What do we need? This x1 do we need, right? Because the question asked is what will be the center of mass of the remaining part. Remaining part is nothing but m1, right? M2 is removed from it.
Yes, sir.
So I am trying to adjust this formula. m1 x1 is equal to m1 plus m2 into x center of mass minus m2 x2. Got it?
Yes, sir.
x1 is equal, if you did not understand, tell me. m1 plus m2 into x center of mass minus m2 x2 divided by m1. Got it?
Yes, sir.
Now this can be rearranged as m1 plus m2 can be written as total m, right? Total mass of them.
Yes, sir. Total mass.
Total mass into x center of mass minus m2 x2 divided by m1 can be written as, what I will do is plus m2 minus m2 I will add. Will there be any change, right? No change, right?
No, sir.
So m1 plus m2 can be written as capital M, right?
Yeah. Yes, sir.
Did you understand this formula?
Understood, sir.
The remaining part center of mass will be equal to total mass into its center of mass. If entire mass is present, what is the center of mass? Here in this question, that is origin. Okay.
Yes, sir.
Otherwise, generally total mass into the center of mass if total body is present. Okay.
Yes, sir.
Minus the removed part into its center of mass. Okay.
Yes, sir. Understood, sir.
Divided by total mass minus removed mass. Did you get this?
Understood, sir.
This can be further simplified. M can be written as density into area into thickness into, right? Total area into thickness, right? Volume. Density into volume is mass.
Yes, sir. Density into volume.
Volume is area into thickness here.
Yes, sir.
So into x center of mass minus m2 is density into area 2 into thickness is same if it is uniform, x2 divided by m is again what? Rho a t minus rho a to t. Got it?
Yes, sir.
So now can you cancel rho a, sorry, rho a, not a, rho t, rho t common, and can we cancel or not?
Yes, sir.
Now the answer will be a x center of mass minus a2 x2 divided by a minus a2. Got it?
Yes, sir.
Now in books, this formula is rewritten as, very important formula, 5-star formula. In books, this formula is written as like this. A, what is A here? Total area, right?
Yes, sir.
X center of mass is what? The center of mass of the total body present. Total, if entire system is present. Minus removed part, right? This one is removed part.
Yes,
Removed
sir.
part area. Into position or center of mass of the removed parts. And total area minus removed part area. Got it?
Yes, sir.
Now this formula is sometimes written as a1 x1 minus a2 x2 divided by a1 minus a2. But what is a1 here? That is total area. Got it? Instead of
What is total area?
A,
How, sir?
A in books that is taken as a1 for writing
Okay.
easy formula. a1 x1 minus a2 x2 by a1 minus a2. This looks easy, right?
Yes, sir.
That's why. So this is the center of mass of what? This is the center of mass of what? Remaining part. Got it?
Yes, sir.
So in formulas, in materials, you can find this kind of formula. So we don't get confused. How to remember the formula? Total area, if entire mass is present, into center of mass of the total mass minus removed part area into its center of mass divided by a1 minus a2. Got it?
Yes, sir. So
This-
that x com is no, sir. What does that denote for this formula, sir?
This is remaining part center of mass. That's what the question asked, right?
Yes, sir.
Here x1 is right. That x1 is only nothing but x center of mass here.
Yes, sir.
That M1 body center of mass, got it?
Yes, sir. I understand.
Remaining part center of mass. So this formula sometimes can be written as x center of mass is equal to V1 x1. Suppose if three-dimensional body is there, volume entirely directly, because thickness will not be cancelled, right?
Yes, sir.
That means V1 x1 minus volume 1 into x1 into volume 2 into x2 divided by V1 minus V2. Got it?
Yes, sir.
Similarly, y center of mass is equal to y1 minus a2 y2 divided by a1 minus a2. Similarly, z center of mass is equal to here y center of mass is equal to v1 y1 minus v2 y2 divided by v1 minus v2. v1 is nothing but total volume into center of mass coordinate y coordinate of total body minus v2 removed part volume into center of mass coordinate of removed part divided by total volume minus removed volume. This is because density we are assuming to be uniform in these all cases. Instead of using mass formula, I'm using volume and area formula. Like that, Z center of mass can also be written. Got it?
Yes, sir.
This is one good quality. 5-star. You make it a 5-star because 4 or 5 times this kind of concept is repeated in different topics. I will teach when the topics have come. Rotational motion,
Okay.
gravitation, electrostatics. These things is repeated. This formula is repeated. Not formula, but this concept is repeated.
Yes, sir.
Try to make notes out of it. Did you make the notes?
Yes, sir. I wrote, sir.
Drupada, can we go forward?
Yes, sir.
So now solve me this problem then. I gave you the disk problem. So then solve me this problem. Where will be the center of mass of the remaining part lie? Okay. In this question. Wait, the disk is there.
Same formula, no, sir.
Same formula. Because this is mostly two-dimensional, then we can take area formula.
Yes, sir.
The sphere means we will take volume formula. There's a disk of radius r. Out of it, r by 2 radius like this is removed. What is the center? Then where will be the center of mass of the remaining part present? Make it a 5-star question.
Sir, we can use this formula, no, sir, like m1 x com minus m2
Yeah.
x2 divided by.
M1 I did not give, right? Just radius
Oh.
I gave.
Yes, sir. So we can use the pi r square radius, no, sir. Pi r square x1 minus pi r.
No, first one A1 is nothing but total area, right? That is nothing but
Yes,
what?
sir.
Pi r square into total area center of mass will be at center, right? Origin, right? If we keep it is on the
Yes,
x
sir.
axis. That means 0, right? 0, 0.
Yes, sir. Yes, sir.
Minus removed part area is pi into r by 2 whole square. Removed part center of mass will be present at the center of the disk means what? R by 2, right? R by 2, 0. Are you getting this one?
No, sir, I didn't get it, sir.
Array, this disk is there, na?
Yes, sir.
This disk will be center of mass will be at the center of the disk because it's uniform disk.
Yes, sir.
The center of the
Yes,
disk
sir.
will be present at the distance of from origin. How much distant it will be present?
Yes, sir. Understood. Understood, sir.
R by 2, 0. So that means area, removed part area is pi into r by 2 whole square into the center of mass of the second disk. Removed part will be r by 2, right? From
Yes, sir.
common axis. Divided by pi r
Yes, sir.
square minus pi into r by 2 whole square, right?
Yes, sir.
Then if you, this will be 0 anyway, cancel because it's a center. So then pi into r square by 4 into r by 2, that is r cube by 8 divided by, here pi can be taken common, r square minus r square by 4, that is 3r square by 4, right?
Yes, sir.
Pi gets cancelled, r square goes by 1 time r, then 4 goes 2 times, then answer is, sorry, this is minus, here minus is there, minus r by 6 will be the answer, x coordinate. But y coordinate anyway will
Understood,
become
sir.
0, because here also it is 0, it is 0 here. Anyway, a1 y1 minus a2 y2 again will become 0. So answer will be minus r by 6 comma 0. That means r by 6 distance backwards it will be there. Minus r by 6 comma 0 will be the center of mass of the remaining part. Got it?
Yes, sir.
This kind of question can come exam. Try to study. Okay.
Yes, sir.
So now
Sir, in y-axis that pi r by 2 whole square into r by 2, no, sir? But
yeah,
it won't be having any axis.
no, it is 0 right here because it is present on the x-axis. That means y
Yes, sir.
coordinate is 0. So it will become 0. Pi
Yes,
into
sir.
r by 2 whole square into 0. 0 minus 0
Understood.
is 0.
Understood.
In this question, it has become 0.
Yes, sir. I understood.
Hmm.
Because that center of mass is in x-axis, so if we consider y, it will be 0 only.
Ah. This very important question. Similar, not the formula will not repeat, but similar concept. Total 1 minus removed part. Why Drupada couldn't join class? Wait. Hello? Hmm. Hmm. Okay. Now,
What happened, sir?
uh, I'll, so okay. Minus r by 6 comma 0. Got it?
Yes, sir.
Then going back to next important concept. Linear momentum. Linear momentum, what is the formula for a given particle? For if a particle is there, one particle, momentum of one particle is equal to mass of that particle into velocity of that particle. Okay.
Yes, sir.
Momentum vector will have the direction of the velocity vector.
Yes, sir.
Now, for a single particle, the momentum is m into velocity vector. Like that, if for a system of particles is there, for suppose, okay.
Yes.
System of particles momentum is p1 vector plus p2 vector plus p3 vector plus so on. Okay.
Yes, sir.
This can be written as m1 v1 vector plus m2 v2 vector plus m3 v3 vector. Okay, so on.
Yes, sir.
But one important thing you remember, system momentum can be expressed as mass, total mass of the system into velocity of the center of mass. Understand?
Yes, sir.
That velocity of the center of mass into total mass, if you multiply, we will get the system momentum. Otherwise, I'll tell you how to.
I understood, sir.
I'll derive that. Okay. Now p vector, p of the system. Okay.
Yes, sir.
Now, can I multiply with m1 plus m2 plus m3 so on and divide without any problem?
Yes, sir.
So on. So if you multiply and divide, what is the formula? This formula m1 v1 plus m2 v2 plus m3 v3 by m1 plus m2 plus m3. This is like what? B center of mass formula, right?
Yes, sir.
Into m1 plus m2 m2 plus total mass of the system, right?
Yes, sir.
Understand? So
Yes,
P
sir.
system can be, system momentum can be described as total mass of the system into velocity of center of mass. If you know the velocity of center of mass, then the entire momentum of the system can be found out easily. Total mass of the system into velocity of the center of mass is actually the momentum of the system. You don't need to find out each and every velocity of the particle. If particles are given, total is can be found out. If total is given, sometimes one particle is given, other particle can be found out. Okay, this is an important concept. Next, this can also be written as momentum of the center of mass. So next, P system can be written as what? Total mass of the system into velocity of center of mass. Now, if I want to write it as dP by dt, dP by dt, that is rate of change of momentum of the system, that can be written as m of the system if it remains constant. dV center of mass of the system by dt. That is nothing but what? Force, net external force is on the system. If you take some two particles as the system, all the other external forces on the system is equal to mass of the system into acceleration of the center of mass. Got it? This is another important point.
And
So if you figure out if net external force on the system, that is equal to mass of the total system into acceleration of the center of mass. Now, very, very important concept. But generally, what formula we studied in Newton's laws of motion? F net external force is equal to mass into acceleration, we studied, right?
yes, sir.
That is, this mass is the mass of the particle and acceleration is the acceleration of the particle. Here, the same formula can be applied to total system. If total net external force on the system is zero, total net external force is equal to mass of the total system into acceleration of the system center of mass. Center of mass acceleration is nothing but acceleration of the system. Got it?
Yes, sir. Yes, sir.
This is a very important one, another 5-star formula. Now, here comes a very important, very important, another most valuable, on which number of questions in NEET are asked. Number of questions in different topics, modern physics, lot of topics on these questions are asked. If you know this concept, you can easily solve it. If net external force on the system is zero, very important. If net external force on the system is,
0.
then mass of the system into acceleration of the system should be zero, right?
Yes, sir.
That means acceleration of this mass cannot be zero. That means acceleration of center of mass should be.
0.
Otherwise, this is nothing but what? If net external force is zero, means that dP by dt is zero, right?
Yes, sir.
That means dP by dt is zero means what? P is remaining constant, right?
Yes, sir.
That means 2 points can be written as momentum of center of mass system is equal to constant, right? Because it is rate of change is zero. At net external force is zero.
Yes, sir.
That is, if dV by dt is zero, that means velocity is constant, right?
Yes, sir.
Similarly, dP by dt is zero means P is constant, right?
Yes, sir.
So momentum of the system remains conserved. This is called as conservation of momentum. Very important. Now, gun bullet example. Whatever the bullet is coming out, that is due to the internal force, right? That chemical reaction or mechanical reaction in the gun.
Yes,
Is
sir.
So now, due to internal force, will there be any change? External force is zero, right? Internal force will not create any change in that node point also, right? External force should be there to change the momentum. If internal force, node point you can write, internal force of the system cannot change the momentum of the system. Okay, this is
Yes.
only external force should be there. Our external force is zero on the system. That means momentum of the system remains conserved. These are the very important note points. This is also called as conservation of linear momentum concept. Gun bullet problem, that is the same thing. bullet comes out due to the chemical reaction or mechanical. Some guns chemical, there may some guns mechanical. So because there is internal force for gun and bullet system, if you take both of them as system, the momentum of the system will remain conserved even after the bullet is fired. Got it?
Yes, sir.
Initially, momentum of the system is what? Zero, right? Because there's no velocity for gun or there's no velocity for bullet, right?
Yes, sir.
That means M1 V M1 gun velocity after bullet fired, M1 is mass of the gun into velocity of the gun vector plus mass of the bullet into velocity of bullet vector should be equal to zero, right? Because initially momentum is zero. Finally, also the momentum should be zero, right? Are you getting this?
Sir, initially it was 0, finally it will become M1 V1 plus M2 V2, no, sir?
Finally, also it should be zero, right?
Yes, sir. Finally, finally it will move, no, sir? The bullet will move.
Bullet will move, that is different, but momentum of the system should be zero, right? Because there's no external force.
Yes, sir.
So that is zero should be equal to finally M1 mass of the gun into velocity of the vector gun vector plus mass of the bullet into velocity of the bullet vector. The net momentum should become what?
No, 0, sir.
That means mass of the bullet into velocity of the bullet vector is equal to minus mass of the gun into velocity of the gun vector. Got it?
Yes. Just because there is no external force there, so it is equal to 0, no, sir?
So it because initially it is at zero, then finally also it should have zero only in a system moment. Got it?
Yes, sir. Understood.
Now that is why if bullet is going forward, gun will go backward so that it will maintain that zero momentum. Got it?
Yes, sir.
For both of them system. That is why minus you got. This minus indicates whichever the direction bullet goes, in opposite direction gun goes.
Yes, sir.
Recoil speed, that is. If someone asks you what is the recoil speed of the gun, the velocity of gun vector is equal to minus mb vb vector divided by mg. This is the velocity direction, but only magnitude if you want mb vb by mg, you will get the velocity of the gun. Got it?
Yes.
That is, on that principle only this concept is based. Like the number of questions will be asked. Suddenly a bomb is exploded. Bomb is exploded means after explosion the net which is on the ground. Initially the momentum of the bomb is zero. System entire this bomb is zero. After that also how many let the particles be n. All the n particles momentum should become how much? Zero. Because the explosion of bomb happened not due to external force, due to the chemical internal reaction that has happened.
Yes.
Got it?
Yes, sir.
That kind of question. Then suddenly a kind of question will be asked like this. A ball is thrown, a bomb is thrown like this. So when the bomb is at this place, suddenly it got exploded. So now one particle is exactly retracing its path. Other particle, how it will go? How will it go means now also the center of mass of the system will go in projectile only because it happened not due to an external force, due to internal force. So center of mass will again have the same path. Now both the paths combined will have this path, center of mass path, projectile path. Got it?
Yes, sir.
I'll repeat once again. So now you throw a bomb like this. Generally, if there is no explosion happened, how should the bomb go? Like this, right?
Yes, sir.
Now suddenly bomb got exploded here means two parts if got exploded. One part is going like this, but other part will go like this, right?
Yes, sir.
So now what does it say? But still, how to get the motion of them is both of their center of mass actually will move in this direction only because center of mass should not change its path because whatever that has happened due to internal force, not due to external force. Center of mass path will not change. Got it? Got it?
Yes, sir. Understood.
This kind of questions will be asked. Number of questions you will have in your material and previous year questions also. This is very crucial topic. Then net external force is zero. Acceleration of center of mass is zero. That means otherwise momentum of the system p initial of the system should be equal to p final of the system. system. Okay. That is velocity of the center of mass will remain constant. Acceleration 0 means what? Velocity of the center of mass remains constant, right?
Yes, sir.
Center of mass velocity will not change. Like this in projectile motion. Can you see? Center of mass is remaining again going in that same place only.
So when the this direction, it is like a P initial is equal to P final. When it has magnitude, then P initial is equal to minus of P final, no, sir?
That is
Because
direction. Direction
direct,
also minus means direction also will come. Magnitude means finally that will be 0. Opposite means both will have same magnitude. Got it? Okay.
yes,
So then impulse also. Just notes you wrote, right?
yes, sir.
Impulse also the system. Impulse is equal to in delta p change in momentum, that is equal to p final minus p initial. This can also be written as impulse is equal to integral dp, that is equal to integral f dt. Another formula, f is equal to dp by dt. So dp is equal to f dt. This I taught in first class or some second class, if you would have remembered my class. So integral dp, you remember this? This will give ft graph area will give integral dp, that is
Yes,
change
sir.
in momentum impulse. You remember?
Impulse will then give.
That is delta p, that is p final minus p initial, will be got by area under the curve ft graph. Got it?
Yes, sir.
Suppose like that impulse of the system is asked, that is delta p of the center of mass, change in momentum of the center of mass, that is f external into dt. This is for a particle, this is for a system. Got it?
Yes, sir.
Did you write the formulas?
Yes.
Can you go ahead? One good quality question from this concept only. There is an one of the previous year NEET asked on this concept. There is a ice or sea water like this. Otherwise, some boat is there of this sort. Some boat, L length. So now a man is standing on the boat. Then this surface is frictionless. Okay. Water boat you have no friction. Now the man wants to go from here to here. Okay. The question can be asked is how much distance the boat has moved backwards. Okay, that can be the question.
Yes,
Okay.
sir.
Are you understanding?
Yes, sir.
Is it confusing?
No, sir.
Tell me.
No, sir.
Now the question is like this. A boat is there which is on a frictionless surface, like on a sea which is frictionless. Now man standing on the boat will move from one point to another point at other end of the boat. But will he actually travel? How much distance the man has traveled? Is it length L? Tell me.
No, sir. With that length, you will travel along with this direction, no, sir. Water also.
Water, this boat also will go backwards, right? So he will not exactly travel the L distance, isn't it?
Yes, sir.
Now the question is asked, how much distance is actually the man traveled? He has gone from one end of the boat to other end, but how much distance he actually traveled? That is not equal to L. Got it?
Length plus that speed of the boat, sir. If we calculate speed, then distance by time.
But in other words, we can say take in terms of x also. Speed is equal to distance by time, right?
Yes, sir.
Same
That was.
time they're happening. So we can take in the times of uh, displacement also. Okay. So what I will do is, I'm considering man has gone at, suppose, so now this is the boat, man is here. So now I am considering boat has gone backwards. Okay. So man has reached which place? From here to here, right?
Yes, sir.
So now boat, I am considering boat has gone a backward distance of suppose x1. Okay.
Yes, sir.
Man has gone a forward distance of x2. Okay.
Yes, sir.
But x1 plus x2 is how much magnitude wise? X1 length plus x2 in magnitude.
Yes, sir.
How much? Length L, right?
Yes, sir.
You see, this x1 and x2 you add, length of the boat you will get.
Sir, if the person moves to x2 and the board is moved.
Person moves a distance of x2. By the time the boat has moved a distance of x1, and automatically the person has reached the end of the boat like this. The person has reached this point.
Yes.
No?
Not so clear, sir.
Uh-huh.
Sir, I didn't understand, sir. Like,
Okay, okay. This is a boat, right?
yes, sir.
Total length how much? L, right?
Yes, sir.
Man is standing here.
Yes, sir.
While the man is moving forward, boat will also move backward, right? Because there is no net external force.
Yes, sir.
No net external force means momentum of the system should be conserved.
Yes, sir.
That means what? M1 V1 vector plus M2 V2 vector should also be 0.
Yes, sir.
That means M1 V1 vector is equal to minus M2 V2 vector, right?
Yes, sir.
This can be written as M1 dx1 by dt is equal to minus M2 dx2 by dt, right?
Yes, sir.
That means M1 into delta x1 dt if we cancel it is equal to minus M2 into delta x2, right? Are you getting?
Yes, sir. Understand.
In that way, I'm trying to figure out distances. So man, I'm considering this is the our origin x-axis. So this is x and y axis. So man, suppose he started traveling, and I am assuming the man has traveled x1 distance. How much? In the forward end. By the time he has reached the end of the boat, end of the boat means boat end also has traveled to this point. Okay. Because while man is moving forward, boat will also move backwards, right?
Yes, sir.
Are you understanding?
Yes, sir. Understanding, sir.
Boat, how much backwards it went? I am taking it as x2.
Yes, sir.
Now this x2 plus x1 is how much? Tell me.
The length, sir.
Length of the boat, right?
Yes, sir.
You see, one end of the boat is here, other end of the boat is here. So this end to this origin is x2, and that end to man has gone till here. That will be x1, right?
Yes, sir.
Now this is the actual distance traveled by the man, x1.
Sir, the man is in middle of the boat, sir.
No middle of the boat. It has gone to the end of the boat.
Yes, sir.
You did not understand it, right?
Then I'm like thinking in the logical, like if we go from here to here, by the time it will cover double now, sir.
How double? Wait. Okay.
Sir, if he's going from here
I'll
to here,
tell you one thing. For suppose I'm considering as of now. Man, example I'm taking. Okay. Man has gone from considering boat length is 10 meters. I'm assuming this is not the answer of our question. 10 meters. Then the man started traveling. Boat also will travel behind, right? Backwards.
yes, yes, sir.
So I'm assuming boat end has come here.
Yes, sir.
Boat will come backwards, right? This one you're understanding or not?
Yes, sir.
So when boat has come backwards, so now the new boat position will be like this, right? I'm considering boat has traveled how much distance? 5 meters. Okay.
Yes, sir.
5 meters back it has come. The new boat position will be here, right? Sorry, I will take two colors. Black color is old boat position.
Yes, sir.
Green color is new boat position.
Yes, sir.
So the man has reached the other end means how much distance he traveled. This much only, right?
PL, sir. Understood, sir.
Now, if boat has gone 5 meters backwards, man has gone 5 meters forward, right? Isn't it?
Yes.
If boat has gone 4 meters backwards, then man has gone how much? Just forward.
Yes, sir.
If boat has gone 3 meters backwards, man has gone 7 meters forward. Is there any toughness in this?
No, sir, understood.
That question you need to solve by using this concept. Center of mass should remain again the same point. By using this point, what I will do is M1 initially M1 M1 x1 vector plus M2 x2 vector should be equal to how much? 0, 8?
Yes, sir.
Change in position, whatever the displacement has happened.
Yes.
M1 I'm considering is a mass of the man, and M2 I'm considering it boat.
Yes, sir.
So displacement of man x1, boat is x2. Now the center of mass of the system should remain 0, means m1 x1 plus m2 x2 is equal to 0. It means what is m1 x1 vector should be equal to minus m2 x2 vector, right? Got it? But carefully see here, m1 into x1 forward. X1 vector is how much? X1 only he traveled, right? Forward. Isn't it?
Yes, sir.
But x2 can be written as minus m2 into x2 can be written as how much? Tell me. X2 is written as L minus x1, right? In magnitude terms.
L minus x1.
X1 plus x2 is equal to L, right? In magnitude. This is x1. This is x2. Why are you taking this much time? Am I not making it clear for you?
No, sir, I'm understanding, sir. Seriously.
So x1 plus x2 in magnitude is equal to length L. Got it? Then x2 in magnitude is nothing but L minus x1, sirf in magnitude. Okay.
Yes, sir.
Okay. Then this x2 vector can be written as how minus m2 x2 vector can be written as how much?
Minus x1.
L minus
X1.
L minus x1. Okay. This minus indicates the backward it is going. Got it? Okay. Now m1 x1 is equal to minus m2 L. Sorry, this L minus x1, is it going in backwards or not?
Yes, sir.
Backwards means you will apply minus, right? Total. Vector. Removing vector and making minus. Okay. No?
Yes, sir.
So this will become minus L plus x1 plus m2L minus m2 x1. Got it?
Yes, sir.
Now minus m2 x1, if it comes to the left side, it will be m1 x1 plus m2 x1 is equal to m2L, right?
Yes, sir.
So x1 is equal to m2L by m1 plus m2. Got it?
Yes, got it.
This is like that. X2 is equal to backwards it gone. That will be m1L by m1 plus m2.
Wonderful.
But don't blindly write the formula. Why? Because why I'm saying is this is the distance that is traveled by man in the forward direction. This is the distance traveled by boat in the backward direction. Got it? But question will be asked sometimes. What is the distance traveled by center of mass? What is the distance?
Yes, sir.
What is the distance traveled by?
Center of mass.
That is equal to 0. The center of mass should not travel. That is why we have solved all the things.
Oh, yes, sir.
One year exam, this question is answered. What is the distance traveled by center of mass? Students started applying these formulas. Asked is not either man or either boat. The question asked is about the center of mass of both of them. It will still remain at the same place.
Center of mass is conserved.
Huh?
Center of mass is conserved, no, sir.
Center of mass, because net external force is 0. Man and boat are changing because of internal forces. Because of it, there will not be change in any actual momentum of the system should remain conserved. Then center of mass of the system should remain in the same place where it is there initially. If center of mass has an initial velocity, it should go with the same velocity. Got it? This is the quality. Otherwise, simply this question, if vectors wise you're getting that. What did I say? Another way, simply I'll tell. In magnitude wise, I'll do. Whatever the momentum it has in the forward direction, that much magnitude momentum this should have in the backward direction. Right? Magnitude wise. Direction means minus also comes in. Otherwise, left side momentum should equal right side momentum. Then it gets cancelled out each other. Right?
Yes, sir.
Left side momentum is how much? M1, right?
Yes, sir.
That should equal to right side momentum. Only magnitude I'm dealing with. M2, X2. Got it? Did you understand this or not? Only magnitudes I'm dealing out. Because both I took in the opposite.
Yes, sir.
M2 into X2 is how much? L minus X, right? X1.
Same method.
Same method. So M2 L minus M2 X1. Because no confusion will not be there. Regarding minus. Your answer will be again X1 into M1 plus M2 equal to M2L. So X1 is equal to M2L. M1 plus this formula X2 is equal to M1 plus M. Substitute L minus X. This is a quality. So a lot of questions will be based on this concept. We'll do some fun problems on this.
Yes, sir. So
Okay.
this chapter is small or it's big, sir?
Topic is smaller. It's an important topic. Okay. Next one is collisions. Collisions I'll send the video.
Yes, sir.
It's because these topics are also recorded, but actually that laptop is not with me. That's why I'm unable to send the link.
So this chapter is over, sir.
No. You have some problems we'll solve on this, and collisions I'll send you the video. That means it's over.
Yes, sir. Sir, sir, if you are